Hi everyone. In this tutorial we're going to build a parametric bridge. Now this could be something that you see in the jungle or in a playground, but it's basically going to be built out of sections that we align on a curve, and we will define some sort of a section for this bridge and do kind of a replication using perpendicular frames. I'm going to show you how this looks like in 3D here. So you can actually customize this its topology. So basically, if I shift it to any type of different direction, you can see that it aligns perfectly fine to that. So we're going to look at parametrically building something like this for this tutorial, and I'm going to do this from scratch. So let's start a new document, and we are actually going to first draw it flat and look at what's happening when we divide a curve to build some sections. So I'm going to link that curve into Grasshopper using curve, then do set one curve. So now we have this curve loaded, and we're going to work with perpendicular frames. Now perpendicular frames are located under curve and division. So these we're going to start small, so let's start with 5, and then we're going to build our way up. So let's say we have 5 planes. Now the visibility of these planes could be a bit too much, so you might want to scale your line up just to space them out a bit. And initially what I want is to build a profile along these curves. So that profile could be any way you want. We're going to start with the floor or the base of the bridge on which we will walk. So that is going to be constructed using the coordinate system on the perpendicular frame. So you can see that we have two coordinate axis on this perpendicular frame. So the red is the x-axis, and the blue is the the green is the y-axis. So we're going to use the y-axis to define some sort of an offset for the first 2 points that we're going to evaluate. So we can create points on a plane using point oriented. So I'm going to get the frames, and the UV and W parameters stand for plane aligned point coordinates, so they're like x, y, z. So as I mentioned, U moves the point along the x-axis. So let's see where it goes. So you can see that it's going along the red axis when I move it, and V connects to the y-axis, so we can actually change the x, y, z location of these points using the coordinate axis. For the first 2 points, I want to create some sort of an offset property. So let's say that I disconnect the U parameter. We want the width of the bridge to be 2 units. So I'm going to go 1 unit in the positive direction, and I'm going to make a copy of the point oriented and multiply it with -1. And this -1 will connect to V parameters. So you can see that when I move this parameter single-handedly, we are changing the kind of offset value for the base of our bridge. And we need 2 new points for the rails. So let's say we can define them any way we want. We can also define a custom shape for the section. This could be a triangulated bridge, for instance, or it could be any other profile that we like it to be. So for the other 2, we can simply grab these 2 if you wanted to make it like a box profile, or we can make it any other shape as well. But I'm going to first make a copy, and for these, the U parameter is what constrain us. So I'm going to grab the same number slider and feed in 2 U values to that as well. So we created kind of a higher version of the initial points along the coordinate system. The next step is to actually turn this into a profile. So we can do it by a bunch of ways. So basically, I can actually merge these points, but merging them simultaneously is a bit tricky, because if you look at here, we have 6 planes and we are getting 6 points separately. And what I want to do is kind of cluster these per plane. One way of doing it is to feed all these streams individually, and grafting actually takes care of that. So if you plug these into merge, and under the merge, if you right click here and do graft, what will happen is when we do each input the same way, they will be treated as a separate list. And this will actually merge them into corresponding lists with their data paths. So here you can see that we have 6 resulting lists with 4 items, and those are points grouped under their perpendicular frames. So if I do a polyline going through those, now we have a Z shape that is being drawn. It's because of the ordering of these points. So we may want it to go any different way, but let's say that we start from one of these higher points. Let's say we start with this one. So I move this to D1. I go to its bottom coordinate, which is this point here. And I want to move to the adjacent one at the bottom and then end on the top. So this is the U profile that we came up with. So the frames are kind of confusing us, so I'm going to hide them. So you can see that these are now the profiles that we have aligned onto the spine. Onto the spine of the bridge. And because we grafted the data, we can actually create more frames. So if I increase the number of frames, you can see that we can multiply the amount of sections we want on this bridge. Now, one tricky thing is to actually combine these geometries. For instance, if I were to loft them, so let's say we loft them. Because the data is grafted, it won't take individual profiles as a list. So to get rid of the grafted data, we need to flatten them out into a single list. So if I right click here and do flatten, that takes care of that. So now they're placed into a single list. Now we can loft it. And when you look at the loft, you can also see that we are lofting all of these profiles, but let's say that we want to loft only the bottom half. And how can we achieve that actually? So another thing I can mention is, because we are drawing polylines, there is also a function to draw close polylines. For instance, if I do a Boolean toggle here, or you can right click here and set Boolean to be true, but if I plug in true, that will create a box profile for the planes, and this will basically be a lofted closed shape. But what if we want to get the bottom half? How do we do that? So one way of extracting that could be made by exploding individual polylines, and then you will get individual line segments, and we can go through these line segments and loft that data as well. For instance, I can do a list item here. When we explode a polyline, we get 4 line segments and 5 vertices. So I'm going to go through the line segments and go all the way up to 3. And here you can see these are the top segments, these are right side, these are bottom, and these are the left side. So when the index is 1, that gives me the bottom faces of our bridge, and I can actually plug these into loft and do another flatten here so that we only get the bottom side of the bridge. One other thing I want to do is play around with these points a bit and connect them in different ways. So let's say we want to connect them diagonally as well. So how can we do that? For instance, let's say we grab the bottom and the top corners on the same faces. So these two groups actually correspond with each other. So I'm going to move them out a bit, and we can use shift list to actually connect them. So shift list, basically shifts the data in this list. So for them to connect diagonally, the point group at the bottom needs to be shifted by +1, and the point group on the top needs to be shifted by -1. So we want to filter the first point of the bottom list and the last point of the top list. So I can create -1 to 1 as kind of a number slider here, and another Boolean toggle. So we don't want to do any wrapping, so this is going to go to wrap values as false. So I grab the bottom values, I plug them into the list, and let's look at what's happening when we shift it by -1. You can see that the bottom left point is gone, it's filtered out. If I do 0, there won't be any shifting. If I do +1, the right point is gone, in this case. So let's do something similar to the other list. So I grab this top row points, and this one we don't want to feed in +1 because then the two data lists will align vertically. We want to do another copy here, and this one we want to do -1. So if you select both of those, now you can see that they're actually two lists that look shifted, and you can only see it by drawing lines between them. So if you connect them with lines, you can see the data ordering at the bottom list. You can also do point list here to look at the data ordering. The data goes from 0 to 9, so that's the first point. Because we shifted it by 1, the right point on the unshifted list is gone. And for the top, that's also the similar situation. The data is going from 0 to 9, but the last point of the earlier list is filtered out. So the point list can show you actually how the data ordering is done under the lists. So we were able to do it this way for this group of points. We can actually make another copy and feed in the adjacent points, and that will give us kind of a similar triangulated version, but we can actually change it as well. So we can actually make it 1 for this side and -1 for the other side. So that will go in the opposite direction. You can also do other way around. So for instance, I can make another copy here and do +1, -1. So that will create this sort of X bracing. And I can keep adding these sorts of data matches, right? So we can do the same here as well. So this would be -1, this would be +1, so that will create another X shape there. And we can input all of them to the same curve list as a final operation, so you can get these pieces. And I can also input the polylines to there as well. So we now have pretty much the skeleton of our bridge working, and we also have the bottom faces lined up. So the skeleton we can simply pipe to create kind of a nice shapes. Let's do 0.05. And that's basically our structure. And this is the surface of the bridge. Now, the topological model of our bridge is done, but let's try something else. For instance, let's try to shift or change the topology of this bridge and see if it's going to work or not. For instance, we can grab the initial curve and do rebuild. And we can preserve and tangent directions. We can delete input, and we can increase the point count. And let's say we hit OK. And let's say that we move this point down a bit and see what happens. Now, the bridge is shifted down. And that's because once you start changing the topology of the input curve, the bridge might actually, the perpendicular frames might fold directions. Now you can see that the x-axis is pointing downwards. We can actually fix this by doing a few operations. For instance, we can do align planes, which basically aligns planes by using an input guiding plane. So we want to align these perpendicular planes, and because I drew my bridge along the y-axis, you can see that the xz plane is kind of parallel or perpendicular to our bridge. So if I input an xz plane here as my guiding orientation for this plane, you can see that the y is pointing up, x is pointing this way. So let's see what happens. Now these were the initial planes. This is the resulting plane. I'm actually going to plug these in instead of the perpendicular frames to see what's going to happen. Now, because of this alignment, our bridge is shifted towards the left side, which is actually fine. You can actually still rotate this plane. For instance, we can do rotate plane, and we can use rotate plane. We can rotate these planes using some angle values. So let's say we feed in some degrees. We can set this to be -90 to 90. So let's say I rotated them in the -90 direction. I'm going to use these planes for the construction of my points of the bridge. So I'm replacing the planes, and I'm going to hide the planes as well. I'm going to hide the XC plane. Now this is shifting them to the original side, but if you rotate the plane using the plane rotation, all you would have to do is rotate it using a bunch of angles, like 90, -90, or keep it at 0, depending on the topology that you want to set. One reason I'm doing it this way is because if we shift the plane to other types of locations, for instance, we might want it to swerve as well on the XY plane, we may want to actually control how those plane adjustments are going to take place. And we can actually have the starting z values to be higher than the ending values. You can create any type of sag in the middle, and you can also create some swerve in the horizontal direction as well. And that's basically modeling a parametric bridge using a spinal curve, and we used perpendicular frames to actually divide it first into frames, into planes, and then each plane we constructed some points. So these points could be topologically coordinated, right? So I can change the width of the bridge by inputting some of these numeric sliders. I can change its height. So these are some topological properties of our bridge. And here though, we actually created first the bottom surface that we lofted by exploiting the polylines, the sections, and then getting the bottom face curves. And then using shiftless, we created some diagonal bracing. And we can also add one more here for these lines. And you can actually do it by, because we had polylines here, you can actually do flip matrix, and you can draw another polyline here, but we don't want this to be closed, so this could actually go to the curves as well, and that will set kind of a almost like a space frame bridge. And this is only controlled by this input curve, so you can actually change its topology as well. So these lines were used with shiftless to create these diagonal bracings. We also did some functions with the profiles, and at the end we just piped our connections. And that's pretty much it. I mean, you can also play around with these sorts of rotations, alignment. Maybe you don't have to do this alignment, but just do some plane rotation if your curve planes or perpendicular frames flip downwards. You can readjust them using plane rotation, as I did here. You can. This normally takes in radians, but you can right-click here and supply degrees. You would have to probably rotated in the -90 or +90 direction, and you can use it for the point oriented planes as well. And that's pretty much it for the parametric bridge exercise. So if you have any questions, again, you can leave comments below, and the following weeks we're going to shift to other sets of geometries. And I hope you have fun working on this exercise. Basically, you can create a lot of different variations, combine kind of a parkour with this type of geometry. And I'll see you guys next week with another tutorial. Thanks for watching.